Hello, my name is Leonel Ayala, and today I will be explaining question 3 from Assignment 8, Analysis of Dependency and Relationships. This is for Dr. Alemi, HAP 823, Spring 2019. Thank you. We will then select 3 variables from our data set, which include alcohol abuse diagnosis, drug abuse diagnosis, and CIT success. Then we will test 1 complete independence, 3 joint independence, and 3 homogeneous associations. The third step, we will identify the most parsimonious model to fit the data. Here is a description of Poisson regression. Go ahead and choose 3 variables. As stated before, the ones we chose are alcohol abuse diagnosis, drug abuse diagnosis, and CIT success. In the left screenshot, you can see the original data set, and in the right, you can see the edited variables we chose. You make sure to copy and paste into a new worksheet and remove all empty blanks. Next, list all possible combinations of 3 variables. The first screenshot shows you the output with the 3 variables and the CIT count. The second screenshot shows you the count formula. Make sure to save that table as a CSV. It will then be read in R. Here is our first regression. No linkage between any variables. Complete independence Poisson regression. As you can see, both the input code and the output. Next, we will run 3 more regressions, looking at history of alcohol and drug abuse, family history, alcohol and CIT success, family history, drug, and CIT success. Here is the regression for joint independence, Model 1, family history of alcohol and drug abuse. R code input, seen above, R code output, seen below. As you can see, this is a joint independence, Model 2, family history, alcohol, and CIT success. R code input, seen above, R code output, seen below. Next, we will look at Model 3, family history, drug, and CIT success. R code input seen above, R code output seen below. Now that we have seen joint independence, we will move on to see models with full homogeneous model, homogeneous association, no alcohol and drugs, homogeneous association, no alcohol and CIT success, and homogeneous association, no drugs, and CIT success. This is the full homogeneous model, looking at all 3 variables. As you can see, R code input above, R code output below. We'll move on and create a homogeneous association no AD model, which means no alcohol as well as no drugs, as you can see from the screenshots below. Next, we'll create another homogeneous association no AC model, meaning no alcohol and no CIT success, as you can see below. In conclusion, I went ahead and created a table to better depict our final thoughts. As you can see, homogeneous contains the smallest residual deviance with 0.17623 and a degrees of freedom of 1. Based off the model and this chart, we can conclude that the homogeneous method is the best option in the Poisson regression.